Alright, hey everyone. So, well, today we're gonna do a find eventual states. Last time we did course schedule 1, and I decided to skip course schedule 2 because, well, it did not make any sense to do it because we kind of covered it in course schedule 1 itself. Like, there was no much difference to it. Um, Anyways, like, moving forward, now we have, you know, a few things to cover rather. So let's get started with find eventual states. This is a continuation of topological sort series. So uh, the goal is to finish topological sort and then also a few more things. uh, so yeah, let's get started. So, well, we are gonna start with this. So yeah, it says that there are n nodes, which is labeled from 0 to n minus 1. The graph is present in 0 index to the integer array called graph. The graph of I is an integer array of nodes adjacent to node I. So, meaning that, and there is an edge from node I to each node in graph of I. Well, this is the very basic or generic, uh, graph. But let's continue. Before that, we'll write some facts, right? So there are n nodes in the graph, which has been specified, right? Each of them are labeled from 0 to n minus 1. Okay, so there's a graph array, which is this. All right, so this is the adjacency list per se, like 0 is 1 2 and so on and so forth. So moving on, a node is a terminal node if there are no outgoing edges. Okay, what is a terminal node? No outgoing edges, so out degree should be 0, right? Safe node is every possible path. So what is safe node? Every possible path starting from that node leads to terminal node. Okay, every single possible path. Okay, that's something important, right? Like, it should be every single possible path, not some path, not a little bit of path, like every single possible path starting from that particular node that leads to a terminal node. So return an array containing all safe nodes from the graph. Okay, we have to return an array containing all the safe nodes from the graph. Return array of safe nodes, right? Sorted in ascending order, by the way, that's important, right? Okay, uh, now if you look at this graph, there's 0, that's 1. Okay, you have to find, okay, our goal is to find right now out degree nodes. So they are 4 5, sorry, they're just 5 and 6. There is 5 and there is 6 with 0 out degree. The rest of them has you know. Out degree, yep. Okay, now we have to find the safe nodes. Now this is very obvious in terms that uh, it's topological sort. That's because I'm doing a topological DSA sheet and it has topological sort written into it. But I'm gonna find out some ways to figure out the patterns. I think one of the most important one over here that I think would be important is knowing that out degree is 0, because that's where usually, topological sorts are used, where like that's one of the base condition for a topological sort, right? And secondly, what it says is we have to find safe nodes, right? So safe node is the one that leads to a terminal node, and if you don't know this, but like if you do not know topological sort as such, the conditions are pretty simple. So if this is the topological sort graph, your most, or the like the in terms of ascending order per se, you would have uh, more in degree. So out degree will be more over here on the top, right? And as you keep going down, the out degree will be the least, or rather it should be 0, because if it's not, then yeah, that would be a problem. I'm not sure if it's the right thing to say, because I'm not sure about this property. But you know what, uh, let's search for the properties. Hold on. Okay, yes, so I was correct. So there should be at least one node with out degree as equivalent to 0. That is also known as a sync node, right? That's how you make a DAG, directed acyclic graph. So we know for the fact that there will be one terminal node, right? Okay, do we know that there'll be one terminal node? Like, is it a hmm? Well, I think we're gonna assume that there will be a terminal node,